And so this is the last module of the workshop. So congratulations for sticking through it to the end. All right, so the last thing we like to do is give everybody an opportunity to kind of put their newly learned skill set to use. All right, so this is the case study exercise, and what I'm going to give you the opportunity to do is load in a data set, and we'll talk about the data set in 1 second, and go through, scroll, the questions that are outlined here, starting with some summary statistics about the clinical factors, and then proceeding on with analysis of the RNA-seq data and differential expression, clustering, and then some survival analysis relating the gene expression data to survival outcomes. Okay, now I don't expect you to get all the way through all these problems in an hour and a half. If you did, you would be very, very talented, and we should probably hire you. I give you kind of like the complete set, and then I also provide solutions for this, so that depending on people's time, they can go through it on their own and then look and compare, see what the solutions say. But hopefully, you have a chance to at least start working through this. If you have any questions, I'm going to be here to help answer them. And let me go through the data set. So the data set is head and neck cancer data from the Cancer Genome Atlas, TCGA. We talked about this on the first day, where we went through steps of downloading the data, obtaining it, and then doing some processing to it at the end of the processing, we produced these 2 files. So that's our starting point for today's, or for this part of the workshop. All right, so all of those materials are available on the box folder. Hopefully you've downloaded it now. It's it's in a folder called Case Study on Box. Okay, and so if you haven't downloaded it, please go do so now. Hopefully it won't be too slow. There's only one file. The RNA-seq file is a little big, like 42 megs, but hopefully it won't delay everyone too much. Okay, so you should download that, and then the first thing you want to do, and then put that, put all those files that are there into some folder that maybe you could subfolder called Case Study in your Omics workshop folder. Okay, so put everything within that folder, including the data sets. And the data sets are within that case study folder. They're not within the raw data folder. And that's made everything self-contained in that respect. And I think Kevin probably already went over this with you guys yesterday. But after the first day, when we encountered all those difficulties with changing directories and all those issues, we came up with a solution to bypass all that, which is once you're in, I'm going to escape out of here. All right. Once you have all these things downloaded, then just go on the R Markdown file. Okay, and we'll start with this one. The Genomics Workshop 2007 Case Study Exercise R Markdown. Just double click on that. That should pop open RStudio with the Markdown file. And then if you go down here, if you check your working directory, I can't type. Voila, it starts you up in the directory that you want to be in. So no change in directory, no issues with that, no problems whatsoever. You should be able to then just run the code, right, without having to change anything, really. So then you should, so the first part of the code, before I get to the code, actually, I'll go back to here. So right, so we had 2 data sets, the sample data, the RNA-seq data. There's also a description of the data sets in this README text file, which you might find useful, but what I did not do was give a detailed description of all the covariates that are in sample data, mostly because I just did not have time to write descriptions of all those things. So, but most of them are fairly self-explanatory, and I tell you in the case study exercises, for the most part, I tell you what variables to use. And then the other variables, it should be pretty straightforward. I say gender, there's a variable called gender, so you should use that one. Okay, so now, so let's go back over here to RStudio. So right, so these are all the libraries, the packages that you need. And I'm fairly sure you all installed these because these should have all been with the install script that was given to you in advance of the workshop, and I think it's also on the box folder as well. So that shouldn't be any issue. And then, here's reading in the data. Okay. And that should all go without a hitch. Like I said, if you've downloaded everything, have it all in the one same folder, and then double click on the markdown file, then that should all run smooth as silk and be no problems, okay? And it takes a second to read in the RNA the sequence data. So we got data on 566 subjects. For the sample data, there's 32 variables, and you can see them listed here. Oops, excuse me. All right, here's all the variables in the sample data. It's got all the things that we talked about in the day one. Most of it's pretty explanatory, self-explanatory. And then here, the RNA-seq data. And remember, for the samples, the idea is this TCGA, the TCGA barcode serves as our kind of sample ID. And it also links together the RNA data with the sample data, and they're sorted in the same order. So we're good on that. And then I went ahead and put a few additional pre-processing steps, right, for you, because I said we wanted to, we're going to restrict to primary solid tumor samples from patients with known HPV status and none missing survival status. So the first thing is we're going to, up here, restrict to samples of solid tumor type. And actually, let me, hold 1 second, view, zoom in. Okay, so restrict to samples of the primary solid tumor, all right? And then, so that get us down to 520 samples now, okay? So that was the first thing. And then we're going to restrict to samples with known HPV status. So if the HPV status is indeterminate, which there are some like that, then we're going to go and just take those out. There's only 2 of them, so not a big deal, right? Only 2 of these indeterminate. But I don't know what to do with those, because the primary goal of this analysis that we're going to do is kind of comparing gene expression between HPV positive and HPV negative subjects, okay? And then the last bit here is we take, and then we're also going to do an analysis with survival times, with some survival analysis. So we need to take out any subjects that are missing survival times, because that's we can't use those folks. So I just took all those guys out, and this is like a last little step you need to do. To remove the indeterminate level from the HPV status factor, you have to quote unquote refactor it, and then we end up with 516 subjects, okay? And I'll go through this quickly, although, the first thing is just create some simple frequency tables for gender, race, and HPV status, right? And then check and see if there's an association between HPV status and gender. So using a chi-squared test. And then look at the frequency distributions of T stage and N and M stages. So it's just simple tables, okay? But it's those very handy and useful things to know how to do. So that's just kind of like our warm up, so to speak, right? And of course, in the case study markdown file, I put your code right there, right? So that's what you guys should do, is enter in your code for doing the first problem. It's not really a homework, but we'll go first problem right there. Right. And then the next thing is to do some survival analysis. Now, I'll give you to do survival analysis by a whole bunch of things. Of course, if you could decide that you can just do survival analysis for one of these factors, like survival analysis stratified by HPV status, and then be done with it. But if you like to experiment with a couple things, you could also try looking at the effects of gender, how is survival impacted by stage of disease, okay? And I provide you some code for recoding stage of disease because right now they divide up stage 4 into stage 4A, B, and C. And I don't know, there's not really too many subjects in stage 4B and stage 4C, so I just lumped them all together and recategorize that as just simply stage 1 through stage 4. So rather than making you all do that, I gave you some code to, oops, what happened? Oh, I skipped over a line. All right, to do that. So you should be able to just run that code and produce this new factor. And then the thing that if you want to look at survival analysis by stage of disease, you should use this newly created variable stage.disease, okay? And then we get into the RNA-seq data. The first thing is to try to do some preliminary analysis. Well, so some preliminary steps, right? So first things we have to do are transform and normalize the data, okay? And so for a transformation, usually we think of something like on a log2 scale. Normalizing it, we can do something like use the calc norm factors function, which is in edgeR package. And then there's the default is what's called TMM, or trimmed mean of M values normalization, okay? And later on, I have you look at some box plots. Well, actually, no, here I have you generate some box plots. So you generate some box plots first of the log2 transform data that's unnormalized. And after you do the TMM normalization, right, and this VUM transformation, then you can look at box plots of the normalized and transformed data and see the difference, okay? Okay, so yeah, so I jumped ahead. So that's part 3, and then carrying over into part 4. Part 4 is differential expression. And I am partial to using the lemma package for this, so, and the VUM transformation. And so how that works is it does first a transformation into of the counts into log2 of counts per million, right? But that's all just done by the VUM command, okay? And you guys have code from this from yesterday where they went over that part. So that's where you can bring that in and look at that, all right? And then get like a table of differentially expressed genes. In this case, we're looking at differential expression between HPV positive and negative groups. If you want to take it one step further, you could also try adjusting for batch effects by including this batch number variable in the model. So that's kind of up to you. If you feel comfortable doing that, go for it. And if you'd rather just start off with just a 2-group comparison, then obviously that's fine. But in the solutions, I show how to include batch number as a covariate there in case we want to consider adjusting for it. All right, and then the next part is clustering. So starting with the log2 counts per million data that's returned by VUM, right, which is in this, right, the $E slot from the return value from VUM. Then we can do some clustering. And then what I wanted to do was, okay, take the genes that are different, that you find to be differentially expressed between HPV positive and negative, and just consider that subset, and then try to cluster all of the samples, and then check out the results from the clustering analysis compared to what's given between actual HPV status. Do like a contingency table, cluster 1, cluster 2, versus HPV positive, HPV negative. I mean, do they overlap? Do they coincide? The whole idea is to try and see if I've got these differentially expressed genes, can I use these to then completely separate HPV positive and negative? Or is there still some overlap? All right, that's the biological question. And so it's kind of interesting to see what happens there. And I won't give it away, but of course there's solutions. So you can, if you just want to go to the end, not bother with that part, then you can see what the answer is. All right, and then the last part is survival analysis, which basically I have you run a couple different kind of multivariable models. One is based on the backwards elimination after you do some univariable screening. And then the other two are based on the lasso. One lasso model where you start with everything and see what lasso gives you. And then the other one where you use the initial screened genes and then run lasso and see what happens. Okay? And again, what you want to use for that analysis is the data returned by Voom rather than the raw counts, because those are going to be better input into like a Cox model. Okay? And then split it into a training sample and a test sample, so you can fit the data on the training sample and evaluate it on the test sample. And again, this should be code for this from what Dr. Lambo, you discussed with his presentation. And I mean, all these things actually, all these questions are going to take from parts of the workshop, so that the idea is, okay, I learned about this. Now I'm going to actually go grab that code. Can I execute, right, this code in a totally new and independent kind of set of data? So that's the goal. And at the end of this survival analysis, see what model is the best by looking at predictive ability, in other words, C indexes. Okay, I'm going to stop there. And like I said, I know that you guys won't finish this in an hour and a half. It's not like a final exam where you have to get it all done. But I do hope that you start to see how things piece together, and all the different aspects of what you've learned can kind of connect into one continuum of an analysis that all goes together. And I'll be around for questions, so I think I'll stop talking now and just let you guys work on things. And if you get stuck someplace, you have a question, just raise your hand, and